So this is a continuation of our lessons on solid geometry, and we were talking about cylinders and cubes. So today we are going to talk about the cylinders, which we partly discussed in the last video. So in case you haven't gone through it, please go through the previous video. So let's finish the remainder of the cylinder. So let's draw a cylinder first. So this is our base of the cylinder, and we have the top part of the cylinder also. And let's draw the lines. So this is our cylinder. Now we were discussing about how to find out the surface area of the cylinder, and we discussed that the top and bottom are not so difficult, because if you know the area of the radius here, if you know the radius here, and if this is height, so the top and bottom is 2 pi r square. Now the area of the side, if you take a piece of paper, a rectangular piece of paper, and if you try to take from one side and slowly bring it to the other side to make a cylinder, what would be the area of the cylinder, which is basically the area of the rectangle, which is L times W. Now see, if the W becomes the height of the cylinder, so W becomes the height of the cylinder. Now L, if you take the entire length of L, and L becomes the perimeter of this circle. Now try to visualize this. If you take one side of this piece of paper, after you make the cylinder, if you just take one side of the piece of paper and just try to again unwind it, or try to again make it flat, you will see that the length becomes the perimeter of the circle here. So that makes it, what is the perimeter of a circle? Which is 2 pi r, which is our L. So to substitute in this formula, L is 2 pi r and h. So the area of the side surface of a cylinder is 2 pi r h. So now the total surface area, that means, is top plus bottom plus the side surface area. So we have 2 pi r square plus 2 pi r h. So this is the total surface area of the cylinder. Now sometimes in problems you may have to just deal with the side surface area and not the top and bottom. So those are the times you just be careful that which surface area you really need to consider. So that's all about cylinders. Now cylinders can come with different types of shapes. Just let's draw a few ones. So this is sort of a vertical cylinder. Now you can be given a slanted cylinder, which is also the same cylinder, but only it is just horizontally placed. So but the same formula can be applied as long as you know this is, which is R and which is H. So in this particular case, this is still R and this becomes H. So now we know the area of the cylinder. The next one is the volume of the cylinder. Now volume of the cylinder is pi r square h. Now one thing to always remember is the surface area would always be two-dimensional, meaning if you see right here, you have r square and you have RH, which is always two-dimensional. In a volume, we have this has power 2 and this is h has power 1, so that is three-dimensional. Meaning, so always to keep in mind, because at the end you will have so many formula that it might be confused which one is which. So remember, the volume would always involve 3 dimensions and the areas would always involve 2 dimensions. So let's come back to the volume again. So pi r square h. Now one of the trick to remember this is, think about it, a cylinder is as if you take a CD, music CD, and then you stack them up. So each of the CDs has r, and that means the area of each of the CDs is r square. And think as if you take a cylinder and you stack whole bunch of CDs to fill it up, and say you have h number of CDs, and if each CD has pi r square, and when you stack them up, the entire volume becomes the volume of the entire pack of CDs becomes the volume of the cylinder. So each of the CDs is pi r square is the surface area, and you have h number of CDs, so pi r square h. So that's sort of the way to remember. So that's all about the cylinders. We will talk about cones in our next lesson. Okay, one thing we forgot about, the diagonals of a cylinder. So let's discuss the diagonals of a cylinder. So let's draw the long diagonal, which is one side to the another side. So to find out the diagonal, this is our triangle, so which we need to calculate the diagonal. Remember, in most of the solid geometry shapes, to calculate diagonal, you always have to apply the Pythagorean theorem. And for Pythagorean theorem, we have to always find the triangle which involves the diagonal. So for this one, we have this which is h, is this length of the triangle, and this one is, if the radius is r, so this is 2r, right? Because it almost becomes a diameter of the circle. So to apply the Pythagorean theorem, the long diagonal, which is this, becomes h square plus 2r square. So square root of that is this. So h square plus 4r square. So this is the diagonal of a cylinder. So that's all about cylinders. We'll talk about cones and few other shapes in our next lesson.